I'm going to demonstrate ways to check and not to check the input power to the gap generator. In this folder we have tests that demonstrate the ways to check it. And in this folder we have tests that demonstrate ways not to check it. And that's what I'm going to start with. Call up the spreadsheet data. First thing I'm going to do is I'm going to change the magnification to 125%. That way we can view it a little better. Scroll over here where the test starts. And here it is. Now this test was done in neutralization mode only. And what that means is I'm only applying power to the coil for half of each cycle. Now one cycle is 60 milliseconds. So it means half of that would be 30 milliseconds. The input volts and amps are measured at the power supply. And the output, as with all these tests, are going to be to two 1500 watt heating elements and two forklift lights. Now here you can see we have minus 44.83 watts of unity. And so that don't quite cut it. That's not what we're looking for. But right here we have 12 maximum amps input for the first half of the cycle when the power is supplied. And we have an average of 11.57 amps input. Now see this note down here in blue? I later did a 7.5 amp fuse test for 9 minutes and the fuse never blew. I've actually done 3 tests that way and the fuse never blew. So is this information right here right? I don't think so. And I have a note right here. It says, fuse should have blown. Look at column U. So let's just scroll over there and look at column U. Okay, now right here, column U is right here. That's the amps input. Right here's the time, the start of the cycle, volts in, amps in, and the watts in. And this is just one cycle. I extracted out from the 2500 readings the 600 for this cycle. And you can see here that 331 amp readings were over 7.5. So I'm just going to scroll down through here and let you see that. We're coming to the halfway point here. And here it is. Half of the cycle right here. 30 milliseconds. But we're still producing. Still input power. Now here we've started going down in input power. But this is where it stops being over 7.5. So I'm going to scroll on down and we'll go to the end, which is 60 milliseconds. And here we are. As you can see, there's a little bit of power being input here. Or at least that's what the oscilloscope shows. So I'm going to call up another test right here. Well, before I do that, I want to show you what the scope looks like. Yeah, let's bring this down a little bit so you can see it. And there you are. Now the number 1 here is the volts input. Number 2 is the amperage input. And number 3, the purple, is the voltage output. And number 4 is the amps output. Now let's look at this again. And here, this is just showing one cycle. I've changed the timing from 25 milliseconds to 10 milliseconds. You can see right here it is. I'll change it back there. You can see, well, 25 milliseconds, I'm sorry. But anyway, so much for the picture of the scope. Now, I want to demonstrate, or I want to show the power with the last half of the input gone. So, like with the other one, I'm going to change the magnification here to 25%, or 125. And as you can see here, with the last half of input removed. And we're still at minus 16.23 watts of unity. I'm going to show you how I removed that. So let me get all of this in here. Well, we're just showing the input. Like I say, this thing has 2,500 readings. We're going to scroll down here. To the time where it says 0. Right here it is. Start of the cycle. Let me move this over here a little bit. And you can see the start of the cycle right there. It's at 0. Now I'm going to scroll on down here a little bit. On this page down, and we're going to come to 30 milliseconds, which is half the cycle. Right here. 30 milliseconds. So just after that half of that cycle, you can see I replaced the voltage and the amperage here with all zeros. And I continued that down to the end of the cycle, which is at 60 milliseconds. And right here it is. So that's how I did that. So it reduced it here quite a bit, but it's still nowhere near unity.